Welcome to the Twin Labs podcast. Today we are embarking on a deep dive into the world of digital twins, specifically looking at where this incredibly dynamic technology is, well, where it's heading. It feels like every week there's a new application, a new breakthrough, and just understanding the key trends is pretty essential right now.
It really is, yeah. And to guide us on this deep dive, we actually have a fantastic roadmap. It's provided by Twin Labs themselves. It's an article titled Top 10 Digital Twin Trends to Watch. And this piece, it doesn't just, list what's happening. It gives us some really crucial insights into the forces shaping the digital twin landscape, looking ahead to 2025 and really beyond that, too.
Absolutely. So our mission here, really, is to take this insightful source material from Twin Labs, unpack it a bit, go beyond just, reading off the trends, and really understand the core nuggets of knowledge and insight that matter most to you, our listeners. We want to explore why these trends are significant, what potential opportunities they're unlocking across industries, and also the vital challenges that companies and even individuals need to be aware of. Think of this as maybe your fast track to being truly well-informed on the bleeding edge of this really transformative technology.
Right. And maybe just to set the stage, as the article does, it's probably important to ground ourselves again in what a digital twin fundamentally is. The Twin Labs article defines it pretty clearly. It's a dynamic, data-driven replica of a physical system.
Right. And that system, it could be almost anything, couldn't it? Like a single machine or...
Exactly. A single machine, an entire factory floor, a vast city, or even, as we'll get into later, something as complex and, frankly, personal as a human organ or even a whole body system.
Okay, so it's definitely not just some static 3D model you look at once in a while.
No, not at all. It's like a living, breathing digital counterpart. It's constantly updating, in real time. It reflects every change, every input, every variable that's happening in its physical counterpart in the real world.
And the power, the real purpose of having this replica, as the source emphasizes, is to, simulate, predict, and optimize.
That's it. You can run all sorts of what-if scenarios on the twin without ever touching or risking the real-world asset.
Which is huge.
It is. And the article makes it really clear this isn't, futuristic speculation anymore. This isn't science fiction. Digital twins have really matured. They're now critical, powerful tools that are actively driving efficiency, enabling just unprecedented levels of innovation, and also enhancing resilience across, virtually every sector you can think of.
Yeah, it feels like adoption isn't just happening, it's accelerating, really fast.
It is, at a phenomenal rate, because organizations are seeing tangible, significant returns on investment. It's proving its value.
Which is precisely why understanding these specific trends is so crucial now. I mean, the landscape is evolving so quickly that if you stay static, you're basically falling behind.
You are, yeah.
So let's jump into this roadmap from Twin Labs. Let's unpack the first key trend they highlight.
Okay, sounds good.
Yeah.
The number one trend identified is the increasing integration of artificial intelligence. This leads to what the article calls AI-powered digital twins. And it describes them as becoming, quote, predictive powerhouses.
Okay, predictive powerhouses. I like that. This is where it starts to get really fascinating, isn't it? Because AI isn't just sort of layered on top.
No, it's not just an add-on. It's fundamentally transforming the twin itself. The article explains that by integrating these sophisticated machine learning algorithms, the digital twin gains this ability to analyze just absolutely immense data sets flowing in from its physical counterpart.
Right. We're talking huge amounts of data like patterns, anomalies, performance history.
Everything. Patterns, anomalies, historical performance, environmental factors, the whole lot.
And it's this analysis capability, then, that lifts the twin from just being a monitoring tool to something truly intelligent.
Exactly. It becomes an intelligent agent. It allows for these really complex simulations that go way beyond just basic physics. They can incorporate learned behaviors, historical patterns, and crucially, it enables the automation of decisions with incredible precision.
Wow.
Yeah, and the source includes a really powerful insight here from a leading tech strategist who states, and I'm quoting again, AI doesn't just enhance digital twins, it makes them proactive.
Proactive. Okay, that feels like the key word there. That shift from reactive to proactive seems like the core intelligence leap. It's not just showing you what's happening right now, but actually anticipating what will happen next.
Precisely. It's about getting ahead of the curve.
Can you give us some specific examples from the article? How does this proactive AI power actually look in action?
Sure. The source highlights several really compelling industry applications. Take the healthcare sector, for instance. AI-powered twins are being used there to model patient outcomes.
Okay, how does that work?
Well, By simulating a patient's specific physiological system and how it might react to different factors, medications, treatments, lifestyle changes, they can actually predict potential complications before the symptoms even appear.
Wow. So clinicians can intervene earlier.
Exactly. Allowing them to intervene earlier and potentially prevent serious issues from developing in the first place. It's quite remarkable.
Simulating a medical future to enable better care right now. That is a profound application of this tech. What about manufacturing? The article mentioned optimizing production lines.
Yes, manufacturing is a huge area. AI twins can analyze performance data from machinery in real time, identify really subtle inefficiencies or deviations that, a human operator might easily miss, and then optimize the production flow dynamically.
So it's finding those hidden bottlenecks or figuring out why one line is maybe underperforming.
Precisely. And the article gives a great specific example, a car manufacturer using an AI twin to simulate engine performance under incredibly harsh or extreme conditions. Think extreme heat, cold, stress loads, things you maybe can't easily replicate physically, or it's very expensive to.
Right.
This lets them identify potential points of failure virtually, test design modifications, refine the engine, all before they ever commit to building a physical prototype.
That must save immense development time and material costs, catching failures in simulation instead of out in the field after launch.
Absolutely. It's a massive efficiency gain and a quality improvement, too. And then you look at logistics.
Yeah.
AI twins are proving invaluable there for forecasting delivery delays.
Okay, how does that work? Analyzing traffic.
Yeah, by analyzing real-time data on traffic, weather conditions, vehicle performance, even things like driver schedules, the AI twin can predict potential delays hours or even days in advance.
That gives you time to react.
It does. This predictive capability allows the system to dynamically adjust routes or maybe reschedule deliveries automatically. It minimizes disruptions and optimizes efficiency across the entire logistics network.
So these benefits listed in the article, improved forecasting, better anomaly detection, advanced process optimization, they're all direct results of this AI integration.
That's right.
And the article's point seems to be that this isn't just some emerging trend. It's really set to become dominant in 2025. Businesses need this for that competitive edge.
Precisely. It's the intelligence layer that really unlocks the true potential of all the data the twin is receiving. It makes the data actionable, proactive.
And that reliance on getting and processing data in real time.
Oh,
Well, that brings us perfectly to trend number 2 they talk about, the crucial integration with IoT and edge computing. Because digital twins, by their very nature, they are just hungry for live data, aren't they?
they absolutely are. They thrive on it. And the Internet of Things, or IoT, essentially serves as the sensory network for the physical world. It's just this vast collection of sensors and connected devices placed on physical assets.
Like what sort of assets?
Oh, anything.
Yeah.
A pump in a chemical plant, sensors embedded in a bridge structure, environmental monitors in a smart building, you name it. And they're constantly collecting data about temperature, pressure, vibration, location, status, countless other variables.
Okay, so IoT provides the eyes and ears, feeding the twin all that raw information from the ground. Where does edge computing fit into this equation?
Edge computing is critical. It's really the other half of the coin here because of the sheer volume and, importantly, the velocity of the data coming from all those IoT devices. It's often just too much, too fast to send everything back somewhere else.
Back to a central data center, or the cloud, you mean?
Exactly. Instead of sending all that raw data on that journey, edge computing allows for processing to happen at the source or, very close to it, right there on the factory floor or inside the wind turbine or in the power substation.
And why is that immediate local processing so vital for a digital twin? What's the big advantage?
Well, two main things. It drastically cuts down on latency, the time delay, and it significantly boosts scalability. You're not bottlenecked by network bandwidth sending everything back.
Right.
And the article quotes an industry expert who puts it really powerfully. Edge computing lets digital twins react in milliseconds, not minutes.
Milliseconds versus minutes. Okay, when you put it like that, that difference can be huge, right? It could mean averting a disaster in some cases or seizing a really fleeting operational opportunity.
Absolutely. When you're monitoring critical infrastructure, like a power grid or a high-speed manufacturing line, waiting minutes for data to travel, get processed, and for the insight to come back, it's often just too slow. You can't prevent a failure or optimize a split-second decision effectively if you're operating with that kind of lag.
Makes sense. What specific applications does the source highlight for this IoT and edge integration working together?
Well, smart factories are a prime example. You have IoT sensors on pretty much every piece of equipment monitored in real time. And edge computing platforms analyze this data right there on the factory floor,
Instantly.
pretty much instantly. This allows the digital twin to predict maintenance needs based on, say, subtle changes in vibration patterns or temperature fluctuations before a machine actually breaks down. It can trigger predictive maintenance alerts right away.
So moving from just scheduled maintenance, like check this every month,
Mm.
to maintenance based on actual predicted need delivered super fast.
Exactly, that's the goal. And energy companies are heavily leveraging this combination too, to optimize grid performance in real time. By processing data from sensors on transmission lines, substations, renewable energy sources like solar farms right at the edge, they can balance supply and demand dynamically, almost instantly reacting to changes.
Helping to prevent blackouts or integrate renewables more smoothly.
Uh, And in healthcare, this integration enables things like remote monitoring of critical equipment. Think ventilators or infusion pumps in an ICU. It allows healthcare providers to track their status and performance in real time from a central location, getting immediate alerts if something's wrong.
So the article emphasizes that by 2025, this tighter integration of IoT and edge computing, it isn't just a nice to have, it's basically a necessity for getting the speed and reliability you need for truly actionable digital twins.
Yeah, across many industries, absolutely. It essentially provides the high-speed data nervous system for that proactive AI-powered twin we were just talking about.
It all connects.
It really does. It's the essential infrastructure for enabling that real-time distributed intelligence.
Okay, moving on to trend number 3, which tackles a truly global imperative these days, the use of digital twins for sustainability and net zero goals.
Yeah, this is a really critical area where digital twins are having a significant and definitely growing impact. And it's driven, as you say, by that global race towards achieving net zero emissions and also meeting stricter environmental, social, and governance ESG mandates from regulators and investors.
But how exactly do virtual models help achieve tangible environmental goals in the physical world? It seems a bit abstract at first.
Well, they provide this really unparalleled ability to simulate and analyze environmental impacts before they happen. Organizations can create digital twins of their buildings, their factories, their supply chains, even entire cities, and use them to accurately model their carbon footprints, track energy consumption with incredible precision, and predict emissions under different operational scenarios or design choices.
So you can test out changes virtually first.
Exactly. The source includes a very insightful quote from a sustainability officer who said, "Digital twins let us test green strategies without real-world risks."
That's a crucial advantage, isn't it? You can run these complex simulations to see the environmental benefit or the cost of some proposed change before you actually invest the time, the resources, and potentially make a real-world impact, good or bad.
Precisely. Risk-free experimentation for green initiatives. The article provides several great examples. In green building design, architects and engineers are using digital twins to model the energy efficiency of different building layouts, various insulation materials, different HVAC system configurations.
All before pouring any concrete.
Exactly. They can optimize the energy performance virtually to achieve the highest possible efficiency before construction even begins. And that leads to lower operational emissions for decades to come.
So it's saving energy and therefore reducing emissions and costs right from the drawing board stage.
That's the idea. And in the renewable energy sector, digital twins are being used to optimize the layout and operation of things like solar farms or wind parks.
Yeah.
They can maximize energy output while maybe minimizing the physical land use required or the visual impact on the landscape.
Finding that optimal balance.
Right. And the article also highlights how governments and cities are leveraging this. It mentions cities like Singapore, for instance, using city-scale digital twins specifically for planning and managing low-carbon urban zones. They're optimizing everything from public transport routes to building energy use, but on a citywide scale.
So applying that analytical and predictive power of the city twin, but specifically targeting environmental goals.
Yes, exactly. And the article projects that by 2025, reliance on digital twins for sustainable innovation and also for compliance with these ever-increasing ESG requirements, it's just going to grow significantly. They're becoming really indispensable tools, not just for operational efficiency, but for demonstrating corporate responsibility and meeting regulatory demands.
That makes perfect sense. You can actually use the twin to model your compliance and demonstrate your efforts towards those sustainability targets. Okay, trend number 4. This one shifts the focus quite dramatically, and it introduces some really interesting, maybe even slightly thorny complexities. Twin of a customer or DTC?
Yeah, this is where the digital twin concept gets applied to model something far less tangible than a machine or a building. We're talking about individual human behavior.
DTC essentially aims to create a virtual simulation of an individual customer's preferences, their behaviors, their decision-making patterns, and maybe even their potential future actions.
Okay, hold on. A digital replica of how a specific person might behave or react. That sounds, I mean, incredibly powerful on one hand, but also potentially a little invasive.
It does raise those questions, absolutely. The fundamental goal here from a business perspective is to gain predictive power over customer actions. It's about anticipating what a customer might want or do next, based on a really comprehensive model built from their data.
Like a prediction engine for people. In a way, yeah. The source captures this really well with a quote from a marketing innovator. DTC turns data into a crystal ball for personalization.
A crystal ball for tailoring experiences. How are businesses actually putting this into practice? What does it look like?
Well, retailers are using DTT to move beyond just broad customer segments, males aged 25, 34, and instead tailor the shopping experience for an individual user, often in real time.
How so?
By simulating a customer's past behavior, maybe their browsing history, their purchase history, how they engaged with past promotions, the twin can predict the likelihood of them purchasing specific products or responding to certain offers. This allows for hyper-personalized recommendations, maybe even dynamically changing website layouts or app interfaces for that specific user.
Wow. So the twin predicts not just what you might like, but potentially when and how you're likely to buy it.
That's the level of granularity they're aiming for, yes.
Hmm.
In e-commerce, this translates directly into driving hyper-targeted campaigns. The messaging, the timing, the platform used, it's all potentially optimized based on the predicted response from that customer's digital twin with the aim of boosting conversion rates significantly.
And digital marketing teams.
They can use D2C to test entire advertising strategies and refine messaging in a simulated environment using these virtual customers before they launch expensive campaigns to real people, sort of like A/B testing on steroids, but with simulated individuals.
Okay, the potential for boosting engagement and sales through this level of hyper-personalization is clearly immense. But you touched on it earlier, that invasive feeling. What are the critical challenges or risks the article highlights with D2C? This can't be straightforward.
No, it definitely isn't. The source is quite clear that this trend brings very significant challenges, and they're primarily centered around data, ethics, and trust. The ability to simulate individual behavior requires collecting and analyzing deeply personal data.
Right, lots of it.
And that immediately raises vital ethical questions. How much personalization is actually acceptable before it becomes creepy or manipulative? And then there are the crucial issues of data privacy and data governance. How is this incredibly detailed personal data being collected? Is consent clear? How is it stored securely? How is it being used? And who actually owns this digital twin of a customer?
Yeah, these are not trivial questions at all. Mishandling this kind of deeply personal data could have really serious consequences for a brand's reputation.
Absolutely. The article really stresses that if businesses don't navigate these issues with extreme care, transparency, and a strong ethical compass, the potential for eroding customer trust is huge. Imagine a data breach involving a customer's digital twin, which contains this detailed model of their behavior preferences, maybe even predicted future actions. That could be incredibly damaging.
It really could.
So the article concludes that by 2025, yes, DTC is set to reshape customer experiences through personalization, but its successful and ethical adoption is heavily contingent on companies establishing really robust data governance frameworks. They need to demonstrate a clear, unwavering commitment to respecting customer privacy and using this power responsibly. It's a trend with incredible upside, no doubt, but it absolutely necessitates a high level of responsibility.
Responsibility is definitely a key theme emerging here. And speaking of protecting valuable data and systems, trend number 5 feels foundational to pretty much everything we've discussed so far. Cybersecurity in digital twin ecosystems.
Yeah, you can't build these complex data-rich systems without thinking about security from day one. As digital twins become more sophisticated and more deeply integrated with the physical systems they mirror, often connected remotely via these vast networks of IoT devices, they unfortunately become increasingly attractive and, frankly, high-value targets for cyber attacks.
It makes perfect sense, unfortunately. I mean, if you can compromise the digital twin of a critical factory or a city's power grid or its traffic control system, you potentially gain control over, or at least sensitive insight into, the physical infrastructure itself. That seems like a direct pathway to causing serious real-world disruption.
Precisely. The source warns that a successful breach wouldn't just be about exposing sensitive data, like operational plans or customer details. It could potentially be used to manipulate the physical system the twin represents. Imagine shutting down a production line, altering a chemical process, causing a blackout, or creating traffic chaos all remotely via the compromised twin. The potential for operational disruption, safety hazards, or large-scale economic damage is very real.
That's quite chilling.
It is. A cybersecurity specialist quoted in the article issues a pretty stark warning. A compromised digital twin is like a back door to your entire system.
Wow, a back door. Okay, so what specific countermeasures does the source highlight? What are companies doing or what should they be doing to mitigate this significant risk?
The article points to the adoption of much more stringent security protocols, specifically designed for these complex, interconnected, often hybrid physical-digital systems. One crucial strategy mentioned is implementing zero-trust frameworks.
Zero trust. What does that mean exactly?
It means you basically trust nothing by default. Instead of assuming that devices or users inside your network perimeter are safe, every single data exchange, every access request, whether it's to the digital twin itself or the data flowing into it, has to be rigorously verified and authenticated. Verification is based on identity, the security posture of the device making the request, the context. It's constant validation.
Okay, so continuous verification rather than that old model of implicit trust once you're inside the network.
Exactly. The source also notes the development and adoption of specialized digital twin monitoring tools. These aren't just standard IT security tools. They're specifically designed to detect unusual behavior or anomalies within the digital twin environment itself or in the real-time data streams feeding it. These anomalies could be indicators of a cyber intrusion or an attempt to manipulate the twin or the physical system it controls.
It's almost like having a dedicated security twin watching over the operational twin.
That's a pretty good analogy, yeah. And interestingly, the twin itself can be used as a defensive tool. The article provides the example of a utility company using a secure, isolated digital twin of their power grid, specifically to simulate cyber attacks.
Okay, like a digital sparring partner.
Exactly. They can launch realistic simulated attacks against the twin to test their existing defenses, identify vulnerabilities they might not have known about, and develop and refine new security protocols, all before a real attack happens. It strengthens their real-world resilience without putting any actual critical infrastructure at risk during the testing phase.
Using the virtual to proactively protect the physical, that's an ingenious application of the technology itself.
It really is. And the article strongly emphasizes that by 2025, robust cybersecurity practices and infrastructure won't be optional extras for digital twin deployments. They won't be something you bolt on later. They have to be a foundational cornerstone, absolutely essential for building trust, ensuring reliability, and enabling the widespread adoption of this technology, especially across sensitive sectors like energy, healthcare, and critical manufacturing.
It has to be built in right from the ground up. Security by design.
Absolutely. Security can't be an afterthought in these systems.
Okay, trend number 6 takes us from securing individual systems to thinking on a much, much grander scale. The expansion of digital twins into smart cities and infrastructure.
Right. This is about applying the digital twin concept, not just to a single asset, like a wind turbine or even a single building, but modeling entire urban environments and the incredibly complex networks of infrastructure that support them. We're talking roads, bridges, utility grids, public transport systems, water management, waste management, environmental systems, the works.
Creating a virtual replica of an entire city, that just sounds like an undertaking of immense complexity and scale. Where do you even start?
It is incredibly complex, no doubt, but the potential benefits for urban planning, for city management, and ultimately for the quality of life of residents are equally immense. These large-scale urban twins can simulate really dynamic elements like traffic flow across the entire metropolitan area, not just one intersection. They can model the stress on specific infrastructure element, say a bridge under varying load conditions or during extreme weather. They can analyze energy consumption patterns, street by street, block by block, or simulate how pedestrian traffic might spread during a large event.
It sounds like having a constantly updated, interconnected dashboard and maybe even a simulation engine for the city's entire metabolism, its pulse.
That's a really good way to put it, yeah. The city's metabolism. And this comprehensive, dynamic view enables far smarter, more data-driven urban planning and management decisions. The ultimate goal here is to build more efficient, more sustainable, and crucially, more resilient urban systems.
More resilient cities.
Exactly. And an urban planner quoted in the article uses a great analogy for this. A city's digital twin is like its brain. anticipating needs before they arise.
That predictive capacity, but for an entire city, that feels genuinely transformative for how cities operate. What specific examples does the source give to illustrate this in practice?
The article specifically cites pioneering cities like Singapore and Dubai, which are known for being at the forefront of smart city initiatives. They're actively using city-scale digital twins for things like optimizing traffic management in real time. They can identify congestion hotspots as they form and dynamically reroute traffic, aiming to reduce commute times and also vehicle emissions.
So addressing those daily frustrations like traffic jams, but also using it for longer-term infrastructure planning, assessing the impact of new developments.
Exactly. They use the twins to model the effects of proposed new housing developments or new transport links on the existing infrastructure before committing to build them. Utility grids within these cities are also leveraging twins for predictive maintenance of their widespread infrastructure, power lines, water pipes, etc. They use simulations to identify potential weak points in the network before they lead to service disruptions or costly blackouts.
Getting ahead of failures.
Right. And furthermore, urban planners are using these twins increasingly for resilience planning. They simulate the city's response to potential major stressors. Think extreme weather events like floods or heat waves, maybe earthquakes in susceptible regions, or even significant population shifts over time. This allows them to design and implement more resilient infrastructure, like better flood defenses, and develop more effective emergency response plans based on realistic simulations.
So planning for heat waves, optimizing resource allocation during a crisis, strengthening infrastructure against future climate impacts, all tested and refined virtually first.
Yes, exactly. And the article forecasts much wider adoption of city-scale digital twins by 2025. It suggests this will fundamentally change how urban environments are designed, managed, and ultimately made more resilient and livable against future challenges.
Okay, wow. From the vastness of entire cities down to perhaps the most intricate and personal system of all. Trend number 7, human twin, also known as biodigital twin development. This sounds like science fiction territory.
It certainly feels like it, doesn't it? But it's a truly revolutionary frontier that's actively being developed. It involves applying the digital twin concept to healthcare by creating virtual replicas of human organs, specific biological systems, or even potentially the entire human body.
A personalized virtual human body, or parts of it. What is the primary purpose? Why build these biodigital twins?
Well, the core function, the main goal, is to simulate how a specific patient's biological system, maybe their heart, their liver, their lungs, their cardiovascular system, would respond to different treatments, medications, or surgical interventions. The overarching aim is to enable true precision medicine, tailoring medical approaches specifically to the individual patient based on insights gleaned from their unique digital twin, rather than relying solely on population averages or trial and error.
The implications for medical research, for drug development, and especially for personalized patient treatment must be absolutely immense.
They are potentially massive, yes. The source includes a quote from a medical researcher that really highlights this potential quite starkly. Biodigital twins let doctors test therapies without risking lives.
Wow. Testing therapies without risking lives.
Yeah. Imagine being able to simulate the effect of a specific drug dosage or complex surgical procedure or a new combination therapy on a patient's virtual twin before you ever administer the drug or make an incision on the actual patient.
That could dramatically improve patient safety, reduce side effects, and significantly increase treatment effectiveness.
That's precisely the hope and the driving force behind this research. Examples cited in the article include using biodigital twins in drug development. Researchers can simulate how new pharmaceutical compounds interact with virtual organs or specific disease models running on the twin. This has the potential to significantly speed up the traditionally slow and expensive preclinical trial process, helping promising new drugs potentially reach patients much faster.
Accelerating drug discovery.
Right. And the article also mentions the ongoing development of more comprehensive, potentially full-body twins. These are aimed at providing highly personalized health insights, maybe understanding an individual's predisposition to certain conditions based on their genetics and physiology, or optimizing personalized wellness and prevention plans.
Understanding your own specific biological responses and risks based on your personal twin. That feels incredibly intimate and powerful. What are the major challenges associated with this trend? It can't just be the scientific complexity of modeling human biology, surely.
No, The challenges are significant and multifaceted. The source highlights, obviously, the immense technical hurdles, particularly ensuring the required levels of data accuracy and simulation fidelity. Building a useful digital twin of a complex biological system requires incredibly detailed, accurate, and often dynamic data, genomic data, physiological monitoring data, maybe lifestyle data from wearables.
A huge amount of very sensitive data.
Exactly. And the simulation models themselves need to be incredibly robust and reliable enough to provide results that are actually clinically meaningful and trustworthy. If the twin isn't a sufficiently precise replica of the individual's biology, the simulation results are, at best, meaningless and at worst, potentially harmful if decisions are based on them.
Yeah, the stakes for accuracy in healthcare are about as high as they get.
They really are. The article also, quite rightly, touches upon the very important ethical and data governance considerations that arise with handling such deeply personal biological data. These echo some of the concerns we discussed with DTC, but perhaps are even more sensitive here. Ensuring patient privacy, guaranteeing data security, establishing clear and informed consent frameworks for how this highly sensitive information is collected, stored, used, and shared. These are critical challenges that absolutely must be addressed responsibly and proactively as this technology advances.
So while the medical potential is clearly revolutionary, the path forward requires extremely rigorous scientific validation and very careful, thoughtful consideration of how this incredibly personal biological data is handled.
Exactly. The article anticipates significant advancement in biodigital twins by 2025, but it strongly emphasizes that responsible innovation, alongside addressing these fundamental technical and ethical challenges, are paramount for their successful and, crucially, ethical implementation.
Okay, moving on to trend number 8, which addresses a more practical but absolutely essential challenge for the wider digital twin ecosystem to flourish: interoperability and standardization of digital twins.
Yeah, this might sound a bit less glamorous than human twins, but it's incredibly important for scaling the technology. The source points out that right now the digital twin landscape can be quite fragmented. You have different vendors offering different platforms, different modeling tools, different data formats, and often digital twins created within one vendor's ecosystem don't easily integrate or communicate effectively with twins or related systems from another vendor.
So if a large manufacturing company, say, uses one vendor for their factory floor twins and maybe another specialist vendor for their supply chain twins, getting those systems to seamlessly share data or work together can be a major headache, right? Lots of custom integration work.
Precisely. It can be a huge headache, costly and time-consuming. This lack of interoperability creates data silos, it increases complexity for users, and it really hinders the scalability and broader adoption of digital twins, especially for organizations that want to model complex, interconnected systems that span different domains or involve collaboration across different companies.
Like a whole value chain.
Exactly. And according to the article, the push for better interoperability and agreed-upon standards is set to take center stage in 2025, precisely to overcome these hurdles.
Why is standardization seen as the key to unlocking that scalability?
Because, as a tech developer quoted in the article states, universal protocols are the future of scalable digital twins. It's about creating a common language. For digital twins to really fulfill their potential to connect seamlessly across different departments within a large company, or between different companies collaborating in a supply chain, or even between different components of a smart city managed by various public and private entities, they need that common language. They need standardized data models, common interfaces or APIs, so they can talk to each other reliably.
It's kind of like how standard web protocols like HTTP and HTML allow basically any web browser to connect to and display content from any web server, regardless of who made them.
That's a very good analogy, yes. It's about establishing those foundational rules of engagement. The article mentions key organizations that are actively working on this right now. Groups like the Digital Twin Consortium and international standards bodies like ISO and IEC. They're all developing frameworks, reference architectures, and specific standards to enable this cross-platform compatibility and seamless data exchange.
And what are the tangible benefits for businesses once these standards become more widespread and established?
Well, there are several key benefits. Firstly, seamless data integration becomes much easier, significantly reducing the time and costs associated with building those custom connectors between disparate systems. Secondly, development time for new digital twin applications can potentially be reduced because developers can work with standardized models, libraries, and APIs rather than proprietary ones for each platform.
So faster development, less integration hassle. What else?
Crucially, it gives businesses much greater flexibility and avoids vendor lock-in. They aren't necessarily tied to a single vendor's entire platform or ecosystem. They could potentially use the same core digital twin model across various software applications, or even switch platform vendors more easily down the line without having to completely rebuild their twins from scratch.
That freedom and flexibility sound really valuable. It makes the whole digital twin technology potentially more accessible, more flexible, and ultimately more powerful because it allows these twins to connect more widely and easily.
Exactly. And the article predicts that the increasing maturity of these standardized platforms and protocols will be a major driver for wider adoption and increased efficiency in how companies implement and manage their digital twins throughout 2025 and the years following.
Okay, trend number 9. This one brings the digital twin into a much more interactive, maybe even more intuitive and visually compelling space. The integration of digital twins with immersive technologies like VR and AR, virtual and augmented reality.
Yeah, this is all about fundamentally changing how users actually engage with and experience their digital twins. By combining the rich, real-time data and the powerful simulation capabilities of a digital twin with the interactive three-dimensional environments offered by virtual reality VR and augmented reality AR, the user experience is, well, it's completely revolutionized.
So instead of just looking at maybe a 2D dashboard on a screen or maybe a 3D model on a flat monitor, you could actually use VR to step inside the digital twin, or use AR to overlay its data onto the real world.
That's exactly the core idea. You're moving from observation to immersion. The source captures this shift really beautifully with a quote from a VR specialist who says, "Immersive technologies are taking digital twins to the next level, allowing users to step inside their virtual models. This allows for visualization, interaction, and manipulation of complex systems in ways that were previously just impossible. It offers a much more intuitive, visceral, and powerful understanding of the twin and the system it represents."
That sounds incredibly useful, especially for navigating and understanding complex environments like, say, a busy factory floor or a construction site with lots of hidden elements.
It absolutely is.
Yeah.
The article provides some really compelling examples across different industries.
hmm
In manufacturing, for instance, engineers and maybe operators can put on VR headsets to simulate walking through a planned factory floor layout before it's built, or practice operating complex machinery in a completely safe virtual environment.
So training or design review in VR.
Exactly. They can identify potential safety hazards that might not be obvious on a blueprint, optimize workflows by virtually walking through them, test ergonomic designs for workstations, and train new staff on complex procedures, all without needing expensive physical prototypes, disrupting ongoing production, or putting anyone at actual physical risk.
Yeah, testing the design and training staff virtually before the physical build or operation even begins, that sounds like huge cost and safety advantages.
Precisely. And then in architecture and construction, augmented reality, AR, is transforming how people work on site and do planning. Users can hold up a tablet or wear AR glasses while physically present on a construction site and see the digital twin data overlaid directly onto their real-world view.
Like what? What would they see?
They might see exactly where pipes and wiring are supposed to go inside a wall that's already built, or visualize structural steel elements before they're installed, or even just instantly check if installed components perfectly match the design specifications held in the twin. It provides these immediate contextual, real-time insights that improve accuracy, reduce errors, and boost overall efficiency on the construction site.
Visualizing hidden infrastructure or the final intended design right there in the physical space, that must prevent a lot of mistakes and potentially speed things up considerably.
It does. The article lists a whole range of benefits stemming from this fusion of twins and immersive tech, significantly enhanced user engagement and deeper understanding of complex systems, greatly improved training and education for these highly interactive simulations, better and faster decision-making based on more intuitive 3D visualization, and ultimately reduced costs by minimizing the need for expensive physical mock-ups, prototypes, or real-world trials.
And as VR and AR technologies themselves continue to get better, more affordable, and more widespread, this synergy with digital twins feels like a very natural and incredibly impactful progression across all sorts of diverse industries.
It really is. The article highlights that this ability to actually step into or intuitively interact with in these immersive ways will become increasingly vital for getting the absolute most value out of digital twin technology by 2025. It's really changing the human interface with these complex virtual models.
Okay, fascinating. Finally, trend number 10 brings us back to a very critical, very real-world application that impacts nearly every business in some way: Digital twins in supply chain management.
Yeah, and as we all know, modern supply chains are notoriously complex, often global, highly interconnected, and as we've seen vividly in recent years, extremely susceptible to disruption. Digital twins are being deployed now to create virtual replicas of entire supply chain networks.
Entire networks, not just one warehouse or one shipment.
No, the goal is end-to-end, encompassing everything from raw material suppliers and component manufacturers through production facilities, distribution centers, complex transportation routes involving ships, planes, trucks, right down to the final delivery points, and sometimes even customer inventory.
Wow. So a dynamic, living, end-to-end model of how products actually move through the world, from source to customer.
Exactly. And having this comprehensive digital replica allows companies to gain just unprecedented real-time visibility across their entire supply chain, which is valuable in itself. But more importantly, it enables them to actively monitor, simulate, and optimize their logistics and operations dynamically, responding to changes as they happen.
Okay.
A supply chain expert quoted in the article really underscores the significance here, saying, "Digital twins are the key to unlocking resilient and efficient supply chains in an increasingly complex world."
Resilience. That word feels particularly relevant, doesn't it, given all the disruptions we've seen globally in the past few years? Pandemics, geopolitical issues, weather events.
It absolutely is. Resilience is perhaps the biggest driver here. The source details specific actions companies are taking with these supply chain twins. For starters, they are gaining that real-time visibility into inventory levels across multiple warehouses, production sites, even goods currently in transit on ships or trucks. It provides a single, accurate source of truth about where everything is.
So finally, knowing precisely where everything is all the time across the entire global network, that alone must be huge for planning.
It is, and they're leveraging the twins' analytical capabilities, often combined with AI, to forecast demand fluctuations with much greater accuracy. They can incorporate data not just from historical sales, but also from marketing campaigns, economic indicators, weather forecasts, social media trends, and other external factors.
Getting a much smarter demand forecast.
Right. And twins are also being used heavily to optimize transportation routing and logistics networks, figuring out the most efficient modes of transport, the best routes, consolidating shipments to reduce costs and transit times.
Finding the smartest, fastest, cheapest ways to move goods around.
Exactly. But crucially, going back to resilience, these supply chain twins are incredibly powerful tools for simulation and risk management. Companies are actively using them now to simulate the impact of potential disruptions. What happens if a key supplier's factory in Southeast Asia is suddenly shut down by a lockdown? What if a major shipping port like Rotterdam is closed due to a storm or a labor strike?
Okay, running those what-if disaster scenarios.
Precisely. By modeling these scenarios in the twin, they can understand the potential downstream impact on their entire network, which orders will be delayed, which production lines might halt, what the financial cost might be. And this allows them to develop and test robust contingency plans before the disruption actually occurs. Maybe identify alternative suppliers in advance, or pre-position inventory, or plan alternative shipping routes. It helps maintain resilience and business continuity when shocks hit the system.
So they can model the impact of a potential crisis and figure out the best response virtually, hopefully minimizing the real-world damage, cost, and downtime when something inevitably does go wrong.
Precisely. That's the goal. Proactive risk mitigation and resilience building. The benefits are really clear. Much improved supply chain visibility, enhanced forecasting accuracy, significantly increased resilience to disruptions, and better optimized resource allocation across the entire network. The article strongly concludes that for companies operating in today's increasingly intricate and volatile global supply chains, adopting digital twins is rapidly becoming a crucial factor in staying competitive, agile, and resilient throughout 2025 and definitely beyond.
Wow. So looking back at the really comprehensive picture painted by this Twin Labs article, it's quite something. From AI making twins proactive and predictive, to IoT and edge computing providing that essential real-time speed, to all these critical applications in sustainability, understanding customer behavior, enabling smarter cities, revolutionizing healthcare with human twins. And all of that underpinned by vital progress in cybersecurity, in interoperability and standards, enhanced by interaction through immersive tech like VR and AR, and then applied to fundamental business functions like supply chain management. It truly paints a picture of a digital twin landscape in 2025 that isn't just, advancing incrementally. It really feels like it's set for a truly transformative expansion across the board.
It really does. The source makes it abundantly clear that these diverse and powerful trends working together often are poised to dramatically expand the impact and the reach of digital twins across virtually every sector of the economy,
Yeah.
and maybe even, as we touched on, into our personal lives in new ways.
And the overarching message, the key takeaway from the article, seems pretty compelling. The companies, the organizations, even the cities that actively take the time to understand, to evaluate, and then strategically adapt to these key trends now, they're the ones who are going to be best positioned to lead the pack, to really turn the potential of these sophisticated virtual models into significant, tangible, real-world success stories and competitive advantages.
It's really about recognizing that the digital twin is rapidly evolving. It's moving beyond being just a niche engineering tool into an indispensable capability for achieving much higher levels of prediction, optimization, efficiency, and perhaps most importantly, critical resilience in what feels like an increasingly complex and dynamic world.
It really does make you pause and consider, doesn't it? Especially when you build on those bio-digital twin and the twin of a customer trends. Just how profoundly these increasingly detailed, interconnected digital replicas might soon not only mirror the physical world all around us from our vast cities down to our own bodies, but also actively predict and maybe even begin to influence aspects of our physical reality, from how we move through urban spaces to our individual health journeys to our consumer behaviors. It's a fascinating and maybe, yeah, slightly awe-inspiring thought about the blurring boundaries ahead between our physical and virtual future.
Definitely a lot to think about as these trends continue to accelerate and unfold.
Thank you for joining us today. Visit the Twin Labs website for more business insights.